cos of 3x over what? E to the power 2x. So we say basically we know what this can be written as 3 cos x multiplied by 1 over e to the power 2x. And when you change this, it will be what? Cos 3x multiplied by e to the power what? Negative 2x. So you have two functions multiplying each other. We need to use what? Part by part. So we write our arrangement via tech. So now you have your trigonometry and exponential. So we have our trigonometry and exponential. So trig is first before exponential. Some arrangement you will find what is exponential before trig. Yeah, but that we are, the one that we are using is start with trig. So it means we identify our f of x as a what? The first function. Yeah. And we identify g prime as the second function. So we said on the side of f of x, what we do? We differentiate. What is the derivative of this?
Minus 3.
Because it's minus 3 sine 3x. Then what about this? You know this remains the same divided by the coefficient which is minus 2. It's solved. Yeah. So our first step is to introduce that to the formula. So we're going to say f of x. Remember you have identified f of x. Multiply by what? G of x. Minus integral. What do we have again? Derivative. Derivative 3 sine 3x. Multiply by g of x e over minus 2. Yes, don't forget also here. You have divided by minus 2. Our g of x. So yes, we have applied the formula like that. Your f of x times g of x and also f prime times g of x. So already this is part of the solution. Whether you start with your constant negative 1 over 2 or you leave it the way it is, it's also fine. This does not have the integral. But when we come to the integral part, it tells us that we must integrate this. So we can try by starting by simplifying, identifying your constant. Your constant is 3 over negative 2. Take it outside. There's a negative, is over positive. So we have 3 over 2 as our constant. Then you'll be left with sine of what? 3x times what? So part by part can be applied more than once. So it's possible that you still have two functions multiplying each other. You still have two functions multiplying each other. What we must do? We identify again which function will be the first. According to the letter. So it's still trig and still trig and exponential. So it did not change. So what are we going to have? Again, our new f of x and what? So you find the derivative. What will it be now? It will be 3 cos 3x. And then here it will be what? Remain the same divided by minus 3. So already this is part of your solution. You rewrite it the way it is. Therefore, because we want to apply part by part for the second time, we first write our constant that is outside, then you open up brackets. So you write your part by part again. F of x multiply by g of x. Minus integral, right? Remember again, derivative here too. Multiply by your g of x. So it's just to substitute straight on the formula. Hello.
F(x) will be negative 3 sine 3x.
Which one?
F(x).
On the side.
Yeah, this minus
From where? Here.
the top. So, yes.
Or negative 3, ne? Oh. So when you take it outside, it will be negative. Oh, okay, sharp. So it means here we have negative here. So we're okay, Musne? Okay. Therefore, what do we do from there? We can remove the brackets by multiplying, ane? Okay. So it means you will have this, it's already part of the solution. So let's multiply. This negative 3 over 2 is to multiply the constant. And our constant is 1 over minus 2 for these two terms. Okay. So when you take it, it's our positive. Positive what? 3 over 4. And 3 negative 2 over 3 multiplied by negative 1 over. What is that? This is what we write, yeah. Remember we have sine of 3x e to the power what? 2x on this part. Sharp. Again, this negative is multiplied at this one, It's our positive what? 3 over 2. So for now we can just rewrite the way it is, then we'll come back and focus on the integral. So second stage, we can focus on the integral now. So simply means this is part of the solution, this is part of the solution. Yeah. So what will happen? We said we can try to simplify if it's not in the simplest form on the integral part. We identify the constant from the integral part. What is the constant now? What is our constant? It's 3 over negative 2. Yeah, so it means you already have 3 over 2 outside, positive, so multiply by 3 over negative 2. So simply means the solution here is over negative. 3 times 3? 9 over 4, right? Of integral of what? Cos 3x. So this is what we have inside, right? Yeah. So we can see this time around we still have two functions multiplying each other. Whereby we said when we have two functions multiplying each other, we must use by part. But there's something unique that have happened here. Whatever that we have been given or whatever that we are having at the starting point have repeated itself. So we can say we have a repeated function. So what do we do? Instead of us applying part by part, it simply means even if I apply part by part for the third time, I will go back again, maybe 35 pages, not doing the same thing. So to avoid that, we're going to let this to be our what? Our I. Because the original function has repeated itself. So you let it to be I. You let the integral and dx, everything, So now it's our I. So therefore, we can continue. So let's replace. This part, there's no way I'm going to replace here to be I. We don't have integral and dx, So this is part of your solution, cos 3x multiplied by e. I said the order does not matter. Whether you decide to start with negative 1 over 2, it's also fine. And also the second one is still part of your solution because it does not have the integral part. Only to the part where we see the integral part, it must be equivalent to what? Remember we have a constant first, So this part must be equivalent to what? I. But we know very well, since we said EI is equivalent to this, we know the moment I'm not writing anything, I'm trying to tell you what the original equation was remaining like that. I will be writing the original here. So it simply means here we're going to put what? I as well. It's sharp. Okay, so here say applied like times. So it means it's I, then when we transpose this over plus. So let's add what do we have when we add 1 plus 9 over 4?
18 over 4.
Yeah? 13 over 4. 13 15 over 4. Right? Yeah. So at the end of the day, remember now, EI is equivalent to the integral that they've asked us to find. Right, Miss Ne? So simply means if you have obtained or you have find your I, you have easily solved whatever that we are looking for. So what do we do when we want I? You tell me we're gonna divide by 3 over 9. But to make it simple, because we already have a fraction, we can say we multiply by the reciprocal of that number, 9 over 13. But whatever that is done on the left must be done the same on the right. So it means it's 9 over 4. Sorry. So you multiply by the reciprocal. So it means it's 4 over 13. So this will cancel. 4 cancel 4, 13 cancel, so we'll have with I. So what will happen? You can remove brackets, right? So we have a constant. What's our constant here? 1 over negative 2. Then you multiply with 4 over 13. What are we going to get? Negative 2 over 13 cos x multiplied by e to the power 2x. We do the same. This it multiplies here. So we'll have what? This is 3, 3 over 13. So that's what we mean. So because you have managed to find your I, because your I now is equivalent to whatever that we are looking for, so we'll add plus C. So means part by part can be applied more than once, but if we have applied part by part more than once, then it repeats whatever that we have been given to solve. You let that function to be what? To be I. Sharp,